Today we're going to look at three different topics. The first is how the Pythagoreans related numbers to music. The second is three different types of number sequences. And the third is three different types of means. So let's start with the Pythagoreans and music. Now we've already learned that during the time of Pythagoras, the Greeks only knew of the natural numbers or the counting numbers. But they also knew something about ratios, which was a comparison of two numbers using division. So even though the Pythagoreans or the Greeks during that time didn't know about fractions, they did know how to compare two numbers. Now that comparison is what Pythagoras used when he was looking at different notes that were harmonious when he was using a monochord, which is a stringed instrument with one string and a movable bridge, which allowed the string to be shortened to make higher notes. What Pythagoras discovered was that there were certain ratios of comparing the length of the long string, the original string, to the shortened string, which made pleasing notes. And these were the ratios that he discovered were pleasing. Now each of those ratios was given a name. If we think about the length of string from one end of the monochord to the other, and we consider that to be the whole, we can take that movable bridge and move it to a point where we have the original length divided into 4 equal units, and we now have a shortened string that is a length of 3 of those 4 equal units. That gives us a musical note that's considered 1/4 higher than the original note. If we shorten the string so that we think of dividing the whole string into 3 equal units, and then we look at a shortened string that takes up 2 of those 3 equal units, that note will be 1/5 higher than the original note of the original length string. And if we shorten the string so that it is half the length of the original string. So the original string is divided into 2 equal units, and this length is one of those 2 equal units long. We now have a note that will be a full octave higher than the original note. So for example, if the original note played an F, this now will play a note that is still an F, but it's 1 octave higher. So let's suppose that we have an original string that measures 40 centimeters long, and we want to play a note that is 1/4 higher than that. How can we use these ratios to determine where that movable bridge needs to be positioned? Well, in that ratio 3:4, the 4 represents the length of the original string. The 3 represents the length of the shortened string. So we can solve the proportion 3/4 equals something out of 40. And we'll find that the shortened string needs to be 30 centimeters long to play a note that's 1/4 higher than the original note. Now our second topic is arithmetic sequences. Sequences are simply patterns, in this case patterns of numbers, and an arithmetic sequence is a pattern of numbers in which we notice that to get from one number to the next number we add the same amount. In this case we're adding 3. That number that we're adding each time is called the common difference, which is abbreviated with the letter D. So in this case, the D would equal 3 for this arithmetic sequence. To find other numbers in the sequence, we can keep adding that common difference. So if we wanted to find, let's say, the next 2 numbers in this sequence, we could add 3 to the 13 to get 16, and we could add 3 to the 16 to get 19. Arithmetic sequences can also become smaller as long as, to the pattern we're seeing from one number to the next is decreasing by the same amount. So in this case, we notice that we're decreasing by 3 repeatedly. So the common difference for this sequence would be -3. And if we wanted to find the next two terms, we would simply keep subtracting 3 or adding -3 to each number, and our next two terms would be 8 and 5. A geometric sequence also follows a pattern, but the pattern is one of multiplication. So if we notice that to get from one number to the next number in the sequence, we are multiplying by the same thing. So in this case, we're multiplying by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. Then we have a geometric sequence, and that number that we are multiplying by over and over again is called the common ratio, which we abbreviate with an R. So in this case, R equals 2. If we wanted to find the next two numbers in this sequence, we would keep multiplying by 2. So 8 times 2 is 16, 16 times 2 is 32. Geometric sequences can also decrease. So if we look at the sequence 80, 40, 20, 10, what you might notice is that we seem to be dividing by 2. Well, dividing by 2 is the same thing as multiplying by 1/2. So the common ratio is 1/2. One way to find a common ratio is to look at any two consecutive terms in the sequence, for example 80 and 40, and take the second number and divide it by the first number. So 40 divided by 80 is 1/2. The common ratio would then be 1/2. If we continue to multiply by 1/2, we can get the next terms in the sequence. So the next two terms after the 10 would be 5 and 5/2. A harmonic sequence is related to an arithmetic sequence because if we look at the reciprocals of the terms in a harmonic sequence, we will see an arithmetic sequence. So let's look at this from the direction of an arithmetic sequence. We've already seen that 4, 7, 10, 13, and so on is an arithmetic sequence. That means that the reciprocals of those numbers would form a harmonic sequence. So the harmonic sequence would be 1/4, 1/7, 1/10, 1/13. Our last topic is means, and what we're looking at here is a mean between two numbers. The first mean that we're going to talk about you no doubt have used already. The arithmetic mean is also called the average. So you know that when you average two numbers together, you add them together and divide by 2. That's how you find an arithmetic mean. So suppose we wanted to find the arithmetic mean between 12 and 3. All we would need to do is add 12 and 3 together, divide by 2, and we would have the arithmetic mean of 12 and 3. We've already talked about the geometric mean. To find the geometric mean between two numbers, we multiply them together, and then we need to find the square root of that. Now, because to find a geometric mean, we're actually solving a quadratic equation, that means we will have two geometric means between two numbers. So if we want the geometric mean between 12 and 3, we need to find plus or minus the square root of 12 times 3, which is plus or minus 6. To find the harmonic mean between two numbers, we need to double the product of the numbers and then divide by the sum of the numbers. So if we want the harmonic mean between 12 and 3, we need to find 2 times 12 times 3 and then divide that by 12 plus 3, and that would give us 24/5. So that's a quick overview of the things that we need to know for this lesson. If you have not done so already, please read pages 16 to 18. If you need to practice some more problems to make sure you understand what we just talked about, there are some practice problems right after page 18. and there are answers in the back of the book for most of those problems. And make sure that you do the homework assignment on My Gateway before you come to class and before we discuss this in class.